Hello everyone, this is Shrish and today I am going to present my topic Magnetic Properties of Gamma Fe2O3 and its Applications. Now, magnetism. The first thing that comes in our mind is a bar magnet or something which attracts iron. But here we are going to understand it in a different way. So, it is the property of atom that produces a field which can attract or repel other objects. It is a transverse wave caused by the spin of the electrons or protons. A material can be categorized into ferromagnetic, ferrimagnetic, paramagnetic, diamagnetic, and antiferromagnetic. Now, question arises, what causes the magnetism or reason for magnetism? So, we all know moving charges create magnetic field. In quantum mechanics, we define a non-classical property called a spin. And spin magnetic moment is the magnetic moment caused by the spin of elementary particles. The electron is an elementary spin half fermion. Direction of a spin determines the direction of magnetic field. Spin in same direction add up and opposites cancel each other. We define another term called magnetic domains, which are basically a small group of atoms having same magnetic orientation. Now let's dive deeper. In quantum mechanics, the spin of electron has been described by the wave center's positioning to a node of a standing wave. The electron is a stable particle because most of the wave centers are located at wavelengths positioned at these nodes. Here, in this illustration, a tetrahedron is proposed as the geometric formation of wave centers for the electrons. In this configuration, at least one wave center is always off node and it will position to be on the node. The ball in red color you all can see. Once it reaches the node, it forces another wave center off node, and this constant repositioning causes the spin of electron, hence creates a transverse wave. Now let's move to our material of interest, which is gamma Fe2O3. Now it is ferrimagnetic in nature, which means its all magnetic moments are not being cancelled by each other. Coming to its structure, it is cubic symmetry with spinel lattice, where tetrahedral and octahedral sides are partially occupied by iron atoms. Apart from that, crystalline anisotropy along 111 direction makes it magnetically hard, which means even after the removal of the external magnetic field, the direction of magnetic domains will remain same. Now, we know the property of material. Let's see its use. No? So we all know the hard drive and we all know it is being used to store the information in our computer. So here, this is the picture of platter which is made up of aluminium or ceramic based materials. Now this is the head, but over it there is a thin magnetic layer of gamma Fe2O3. Here I present SEM and TEM images of its microstructure. Now, how information is stored? So, writing. There a writer head, which is a strong electromagnet, magnetizes the region by generating local strong magnetic field. So, here we should consider that our material should be easily magnetized in external magnetic field. Now, storing. Magnetic domains remain in the same direction even after disappearance of external magnetic field, which means our material should have magnetic hardness. Now, reading. A reading head detects the magnetization of the region, which is now magnetic storage medium. So, till now we know that hard drives use magnetism to store information in layer of magnetic material. Now here we can see that two continuous R represent 1, and we all know that in computers information is stored in form of 1 and zeros. So here we can also see 1N and 1R represent 0. In this manner the information which is encoded in terms of magnetic domains can be again decoded. Now coming to other applications, Fe2O3 is used in floppy disk, magnetic tapes and magnetic pigments. Now coming to the conclusion. So understanding of atomic structures allows us to understand the material in a better way. Like after understanding the atomic structure, we got to know what causes the magnetism in a material. Simple material properties can be used to develop some great products. Like here we have developed hard disk where we store our information, and we are just utilizing the magnetic property of gamma Fe2O3. Regular improvement is necessary to counter the limitations. Now, with the time, we need faster and faster hard drives to store more and more information. For the purpose, in recent years, cobalt-based alloys are also being used for the purpose. At last, I would like to thank you all for listening me so carefully. Thank you.